Welcome. This is Saravanan, Assistant Professor, Department of AI&DS. Today I am going to handle the subject design and analysis of algorithm. Topic is MET-sort using divide and conquer method. So MET-sort. The MET-sort is a sorting algorithm that we use as the divide and conquer strategy. In this method, the division is dynamically carried out. So divide nothing but the MET-sort is on an input array with an n elements consist of only have three steps we have. First step nothing but divide. Partition the array into two sublists S1 and S2 with n by 2 elements each. Conquer is nothing but sort the sublist S1 and S2. Then combine, we are going to combine the merge sort S1 and S2 in the unique sorted elements. Consider the examples. Now we split it into the list into two sublists. So now 8, 3, 2, 9, 7, 1, 5, 4. We divide into two sublists 8, 3, 2, 9, then 7, 1, 5, 4. Again, this sublist can be divided into two sublists 8, 3, 2, 9. This 7, 1, 5, 4 is divided into two lists 7, 1, 5, 4. Again 8, 3 is divided into two sublists. Then we sort the elements. Then again we are going to divide the 2, 3 into single sublist. We sort the element and combine the elements. Again this 7, 1 we split into two elements 1, 7. Then 5, 4 can be divided into 4, 5. Then we sort the elements. We combine these two sublists, we combine these two sublists, and finally we are going to combine the final list, sorted elements. Algorithm. The problem description is nothing but the algorithm is mainly for sorting the elements using the MET-sort. Input array is unsorted elements, output we have to give the sorted elements by using the divide and conquer method. First, if the low is less than high, then we are going to find out the mid value. So we split the list into the mid elements. Then finally we have the two sublists. One is MET-sort A, first array, low, mid element. Array A is nothing but array element, low and mid. Second MET-sort function is nothing but A, array, mid plus 1. Because we are going to divide the elements, so the second sublist is mid plus 1, high. Finally we are going to combine the solutions low, mid and mid plus 1 and finally high. So this is the example for the combine the array. Okay, k is equal to low, I is equal to low, j is equal to mid plus 1. So both the conditions should be true while I less than equal to mid and j is less than equal to high. If ai is less than equal to a of j, means we are going to k is nothing but is a temporary array. We are going to store in temporary array here. If ai is less than equal to a of j, means copy the smaller elements to the temporary here elements. Then we increment the value of I, then increment the value of k. K is nothing but temporary. Suppose the condition is false, means we are going to store here if a of I is less than equal to a of j, means we are going to store the a of I to temporary value. Suppose the condition is false, means we are going to store the a of j to temporary k, increment the value of j and k here. Then copy the remaining elements of the left sublist to temporary values. Then copy the remaining elements of the remaining elements pending. If a of I is less than equal to mid in, we have to copy the remaining elements of the left sublist to temporary. Here we are copying the remaining elements of the right sublist to temporary elements. So analysis. So in the analysis, the MET-sort, there are the two recursive calls are made here. So each recursive calls focuses on n by 2 elements of list. After the two recursive calls, the one call is meant to combine the two sublists to match the n all elements. So hence we can write the recurrence equations equal to t of n by 2 plus t of n by 2 plus cm. The t of n by 2 is time taken by the left sublist to get the sort elements. T of n by 2 is time to get the right sublist to get sorted. C of n nothing but it is going to combine the two sublists. So we obtain the time complexity of the MET-sort using these two methods. We can also use the two methods to try the time complexity using the master and substitution method. Thank you.